Hope you had an awesome weekend. So this is for my pre-calc class, and we are starting a new unit. So if you didn't have the notes packet printed, that's totally fine. You can just take notes on a separate sheet of paper. We're going to do, it's a pretty short unit. We're going to do some logarithm review. Just because you do use quite a bit of logs in calculus. I want to make sure we're all caught up on it. So we are actually going to skip around. So we're not going to do the first page or the second page. We are going to begin on the third page. So if you have the notes packet printed out, this is the third page. So this is where lesson 1 is going to start. Okay, and your homework tonight is going to be in Delta Math. So this lesson is pretty quick. So it says, think of the word logarithm as meaning the exponent. Think of the equals as saying the word is. So I teach logs a little bit different than you may have realized or may have done last year with Miss Holland, which is totally fine. I teach it with something called Ben the Bunny. So if I have something in Ben form, that's like a base, an exponent, and a number. So the way below here where it says b raised to the p equals x, that's how you may have learned it. I have it as b to the e to the n. So Ben is the name of a bunny. He's adorable. He's super cute. So that's base, exponent is the number. So something in Ben form would be like 2 cubed equals 8. That is Ben form. Base, exponent equals the number. 2 cubed is 8. Okay? And the reverse of that is putting something in log form. So log, where do bunnies hide? Bunnies hide in logs. So we would have log, your base number, your number, equals your exponent. So if I'm using that green example that says 2 cubed equals 8, and that is in Ben form, if I was to write this in log form, it would look like log, our base number is 2, our number is 8, equals our exponent is 3. So going between those two forms. So Ben the bunny. I just think it's a little bit nicer to remember that than like having to switch stuff around. So let's scooch on down. So again, we have Ben the bunny. That's a bad N. Okay. So we want to see, are these correct? So we have, they're just writing their equals exponent on the other side. So like if I was writing this, I would have written it as equals y, just to kind of keep it in that bunny form. So it's easy to remember what pieces go where. So for this one, our base is 3, our number is x, and our exponent is y, which makes sense because then I would have 3 to the y equals x. So these do indeed match up. Below, we have the same thing, bunny. And then we have our Ben. So my base is 7, my exponent is y, and my number is b. So just recalling how to go back and forth with each of those. Okay. So sometimes you'll see a log and it's not written with a base. So for example, log x equals y. When something doesn't have the base written, that means it's a base 10. This is called the common log. So a common log, it's kind of like how when you say the square root, you just write the radical and you don't put the 2 in. It's because it's the most common. So the common log is base 10. So that right there, the 10 is technically there, but when it's base 10, you don't have to write it. You can if it's helpful to you, and if you're going from bunny to Ben form or vice versa, it could be helpful to have that 10 written in there. And then they're just converting it here for us. So we were, oops, we were in bunny form. So B-N-E, and now we are in Ben form. And then similarly with natural log, if you remember Euler's number E, when it's continuous exponential, that would be when natural log and e's come into effect. And remember that ln and e are inverses of each other, so they cancel each other out. We're going to see that in some examples we're going to do. So let's just jump into converting. So we want to write each of these in exponential form. So right now when it's in log form, it's in bunny form because bunnies hide in logs. So bn, technically my e is over here since they said y equals. So if I want to write it in Ben form, it would look like my base number is 5, my exponent is y, and that equals my number, which is x. So 5 raised to the y power gives us a value of x. We can also do that down here. So we are in bunny form, and we want to go to Ben form. So my base number is a b, my exponent is y, and my number is x. So b raised to the y power equals x. And let's also do that in the other order. So right now there's no log, so it's Ben. He's out and he's smiling. Oops, I just changed my color here. So we are in Ben form, and I want to go to bunny form. So bunny. And if we're going to do that, I'm going to have my log. My base number is 5. My number is 6 equals my exponent, which is x. And similarly, we can do that down here as well. Oh, I want a darker green. And my pen froze. Great. So we have base raised to the exponent equals a number. So if I'm going in log form, I'm going to have log, my base is e, my number is 8, and that equals my exponent, which is 3t. Okay, so let's do a little bit of evaluating next. And I'm just going to write Ben the bunny up here as well. So Ben the bunny. Okay. So I'm just going to say these equal x. Okay. Oh, I'll do blue. Why not? Nope, I wanted my green. Just kidding. All right. So right now there's a log. That means the bunny is hiding in the log. So we have my base number and exponent. So if I go to write this in Ben form, that means I have 2 to the x equals 8. So that literally reads as like 2 raised to what power would give me a value of 8? Well, we know that 2 cubed would be 8. So therefore, x must equal 3. And later in the unit, I'll show you how you can use the calculator. But for now, we'll just write it in Ben form, and then we'll evaluate. So log of 100. Since there's no log written there, we got to remember that this is a common log. So therefore, the base is 10. So we have 10 raised to the x equals 100. So 10 raised to what power gives me 100? Well, that would be squared. So it equals 2. Okay. Next, we have my base is 5. My exponent is x. And that equals 1 over 25. So you're thinking, fraction. That's weird. So think of it like this. 25 to the negative 1. So therefore, x would have to equal negative 2, because 5 squared is going to give me 25, but I need to be in the denominator, so we'd have a negative exponent. Nope. Hold on, I wrote that weird. X equals negative 2. My bad. All right, and then next we have natural log of e to the 12th. Well, ln and e are inverses of each other. They cancel each other out. So therefore, x equals 12, because natural log and e are inverses and they cancel each other out. So that's actually where I'm just going to stop for today. So your homework is in Delta Math. Delta Math. And it's just going back and forth from Ben to bunny form and evaluating those, just like we did with these 4 examples. So easy peasy little lesson. If you have any questions, let me know. Tomorrow we'll pick up, or not tomorrow, excuse me, on Wednesday we'll start on the bottom of this page 5. So I hope you have a fabulous day.